Solutions for two triangles. This type of situations arise when you want to find the height of an object by observing it from the different points of observation in the same line with it. Suppose a girl is standing in front of a palm tree and observing the top of the tree at an angle of elevation 45 degrees. The angle of elevation changes to 30 degrees when she moves 11 meters away from the earlier point. Then you can find the height of the tree as follows. According to the given problem, a girl is standing in front of a palm tree. At this point, angle of elevation is 45 degrees. When she moved 11 meters away, the angle elevation changed to 30 degrees. Assume height of the girl as AF. The height of the palm tree is equal to CD is equal to H meters. Length of BC is equal to X meters. From the figure, AB is equal to 11 meters. Angle CAD is equal to 30 degrees. Angle CBD is equal to 45 degrees. AC is equal to AB plus BC is equal to 11 plus X. We know tan theta is equal to opposite side divided by adjacent side. So, from triangle BDC, tan 45 degrees is equal to DC by BC. That is equal to H by X. We know tan 45 is equal to 1, which implies 1 is equal to H by X, which implies X is equal to H. From triangle ADC, tan 30 degrees is equal to DC by AC. That is equal to H by 11 plus X. We know tan 30 is equal to 1 by root 3, which implies 1 by root 3 is equal to H by 11 plus X, which implies H is equal to 11 plus X by root 3. Since X is equal to H, it implies H is equal to 11 plus H by root 3, which implies H root 3 is equal to 11 plus H, which implies H into root 3 minus 1 is equal to 11, which implies H is equal to 11 by root 3 minus 1 meters. Therefore, the height of the palm tree is equal to 11 by root 3 minus 1 meters. Note, total height of the palm tree is CD plus CE, where CE is equal to AF, which is the height of the girl.